Hello, Algebra 2 Honors Kids. Here's the review we did in class today for our quiz 6.2 review. The way this is going to work is I'm going to put a problem up on the board. I expect you to pause the video, try the problem on your own, and then check to see if you have the correct answer. If you do, great, fast forward to the next video. If you don't have the correct answer, then follow me through the problem to see if we can figure out where our mistake is. Okay, here we go. Find the inverse of the function f of x equals 9/2 x minus 5/4. So take a moment, try the problem, and then come back. Okay. Our answer should be y equals 2/9 x plus 5/18. If you have that, great. If you don't, this is how we do the problem. When we start off, we're going to change that f of x to be a y. So y equals 9/2 x minus 5/4. Now, when we're trying to find the inverse of the function, we switch the x and the y. So we now have x equals 9/2 y minus 5/4. And we always want to solve our equation for y. So there's a couple different things you can do at this point. The way I'm going to do this is I'm going to multiply through by the common denominator. The common denominator of the equation is 4. So I'm going to distribute out that 4 to everything. So I end up with 4x equals 18y minus 5. And now I'm going to solve this equation for y. Add 5 to both sides. So I end up with 4x plus 5 equals 18y. Divide each term by 18. Then rewrite it and simplify in my fractions as I go along. So I'm left with y equals 2/9 x plus 5/18. And there you go. Second problem. Find the inverse of this function. Now this problem is a power function, so we do it a little bit differently. Again, try it on your own, come back and see if you have the right answer, which I already have revealed because apparently I forgot to cover it up when I was going through and checking this. That sounds like me. Okay, so the answer you should have is y equals the 7th root of x minus 4 all over 5. So we're going to give this one a try. Again, we're going to switch that f of x to a y. So y equals 5x to the 7th plus 4. We switch our x and our y. So now we have x equals 5y to the 7th plus 4. We subtract 4 to both sides. So we're left with x minus 4 equals 5y to the 7th. Divide both sides by 5. This time we're going to keep this as one big fraction. You can separate it, however. So we're left with x minus 4 all over 5 equals y to the 7th. And how do you get rid of a 7th power? You 7th root it. So we're going to 7th root both sides. Now, we're not going to rationalize the denominator. We're just going to keep it in this fraction as it is. So y equals the 7th root of x minus 4 over 5. Now, if you've separated underneath the root, that is perfectly acceptable as well. And we'd have the 7th root of 1/5 x minus 4/5. Both answers are perfectly peachy. Okay, next problem. Verify using functional composition that the two functions are inverses of each other. So remember, with functional composition, we plug one function into the x in the other function. So we're going to start off, and we're going to plug the g of x function into the x in the f of x function. So we're going to have 3/8, in parentheses, the entire g of x function of 8/3 x minus 16/3. And then we're left over with that plus 2 from our f of x function. We distribute out the 3/8. 3/8 times 8/3 gives us just x. Then 3/8 times a negative 16/3 gives us negative 2. Then we have this plus 2, and negative 2 plus 2 cancels out, so we're just left with x, which is what we want when we're doing a functional composition, checking our inverses of each other. We want to end up with just x. We're going to do the same thing, but in reverse, plugging the f of f function into the x in the g of x function. So we have 8/3 times the entire function of 3/8 x plus 2, and then minus 16/3. We distribute out the 8/3 to the parentheses. 8/3 times 3/8 x just leaves us with x. 8/3 times 2 is 16/3. Then we have minus 16/3. 16/3 minus 16/3 cancel out, and we're left with just x. And because both of these are x, that means our two original functions are inverses of one another. Okay, this next one. Are the inverses of these functions also functions? And then you need to explain your answer and why you said yes or no. So for this one, we're going to harken back and try and remember the horizontal line test. So we're going to draw horizontal lines and see if our horizontal lines cross our graph more than one time. Well, it only crosses it once here, but here it crosses it 1, 2, 3, 4 times. So this would be a no. It failed the horizontal line test. Okay, this next one, we draw horizontal lines. It only ever hits the graph once. So yes, the inverse is a function because it passed the horizontal line test. And this last one, again, anytime we hit the graph, we only hit it one time. So yes, the inverse of this function is also a function. Okay, we're going to graph the function, and then we need to compare the graph with the parent function, and then state the domain and the range. So there's a lot involved in this problem. So take a moment, try it on your own, and then check back to see if you have the correct answer. Welcome back. Okay, so we have y equals -2 square root of x minus 4 plus 3. First thing we want to do is find our Hank and Kelly point. Our Hank and Kelly point is 4, 3. So that's going to be our starting point. 1, 2, 3, 4, 1, 2, 3. That's going to be our starting point. So now you need to do an XY chart to find out our other points. And because this is a square root function, our Hank and Kelly point is going to be our starting point. And from here I usually do 3 in a row. I skip number 7 and then do number 8. You plug each of those in, we get 1, 0.2, and -1. We're going to plot those points. 5, 1, 6.2, and then 8, -1. And our graph looks like that. Now we want to compare to our parent graph, and our parent graph is the traditional y equals the square root of x, which is 0, 0, 1, 1, 2, 1.4, and 4, 2. So how does our red graph compare to our green graph? Well, we need to put a couple things. One, we translated the graph. We moved it over 4 to the right and 3 up. That's one part, is the translation. Then, because this is a negative in our coefficient here, it's a reflection across the x-axis. So this is a reflection. And then also because of that 2 in our coefficient, this also means it's a vertical stretch. A vertical stretch. Okay, our domain, that's always going to be with our Hank and Kelly point. Our domain is going to be x is greater than or equal to, and our Hank and Kelly point starts at 4, so it's going to be x is greater than or equal to 4. Our range is our y value, so y, and this time because it's going down, we're going to be less than or equal to our Hank and Kelly point of 3. Okay, the next one is very similar to this. If you skip the next one, make sure you get the third graph because that's a little different. Okay, y equals 2/3 Square root of x plus 5 plus 6. So we find our Hankin-Kelly point first and foremost. That's the point -5, positive 6. We're going to do our xy chart. Again, we start off with our Hankin-Kelly point of -5, 6. Then we do -4, -3, -1. And then we have 6.7, 6.9, and 7.3. Remember, you can get these by plugging these numbers into your calculator or by using the table function on your calculator as well. So when we graph this, we have -5, positive 6. And then the point -4, 6.7. And then -3, 6.9. And -1, 7.3. Now this one looks a little different than our last graph in a couple different ways. One, our translation. This time we moved to the left, so we went left 5 and up 6. This one did not have a reflection, so it just stays, that part of it. And then we also, this time is a lot smaller than our previous graph and the parent graph. So this is a vertical shrink this time around. And again, you can tell that by the 2/3 as the coefficient here, because 2/3 is in between -1 and +1. That means it's going to be a shrink. Our domain still has to do with our Hankin-Kelly. It's going to be x is greater than or equal to -5. Our range is going to be y is greater than or equal to a positive 6. Okay, try this next one. This one's a little bit different. This time we have 2 times the cubed root of x minus 3. We still start off the same way and do our Hankin-Kelly point. Our Hankin-Kelly point is 0, -3. This time when we do our xy chart, because this is a cubed root, instead of having our Hankin-Kelly point be our beginning point, it's going to be our middle. So we're going to go 2 on either side of this. Again, you can plug this in your calculator, find these all out, or use the table function on your calculator. And we're going to fill in this xy chart. And then we're going to graph this. I always start by graphing my Hankin-Kelly point first. So 0, -3. Then 1, -1. 2, -0.5. -1, -5. And -2, -5.5. And then this is our graph for this function. Our comparison this time around, again, we're going to have a translation. This time it didn't move right or left any, but it did move down 3. And this one also is a vertical stretch. Again, you can tell that by our coefficient here is a positive 2. So it's a vertical stretch. Our domain with the cubed root is always going to be all reals. And our range is going to be the same, all reals. Okay, the last one for target 5 is going to be an application problem. So the speed of sound in feet per second through air of any temperature T measured in degrees Celsius is given by the function V equals 1087 times the square root of T plus 273 all over 16.52. So identify the domain and the range. Well, first of all, which letter is representing the X in this case? Well, it's going to be the T. So the T is our domain. And we want to find out what numbers can we plug in for the T to get out an answer. Well, we see that it's T plus 273. We know that we cannot have a negative number underneath a square root. So what would make that be a negative number in there? Well, anything smaller than negative 273. So our domain is going to be T is greater than or equal to negative 273. Our range means V then, and V, the smallest number that V can be, let's plug in our smallest domain and see what it is. So negative 273 plus 273 is 0. Square root of 0 is 0. 0 times or divided by anything is still going to be 0. And these are going to be greater than or equal to 0 for the range. Part B, what is the temperature of the air if the speed of sound is 1,200 feet per second? So we're going to plug in 1,200 feet in for our velocity. So 1,250 equals 1,087 times the square root of t plus 273, all divided by 16.52. Now, doing this math, I'm going to multiply both sides by 16.52. Then I'm also going to divide by 1,087. They're going to cancel on the right-hand side. On the left-hand side, you put that all in your calculator, and you get an answer out of 19. So 19 equals the square root of t plus 273. And now this is just a basic radical equation you need to solve. You're going to square both sides. 19 squared is 361 equals t plus 273. Subtract 273 to both sides. And you get the wonderful answer of t equals 88. And it's going to be degrees Celsius. Make sure you always label real-world application problems. Okay, moving on to target 6. We're going to start off with the real-world application problem. Read it for a moment, see if you can figure it out how to do the problem. Here are your answers. A is going to be 45.87 and B is going to be 120.97, both meters. If you got that, marvelous. Continue on. If you did not, stick around for the explanation. So here we have our function v equals the square root of 2 times g times h. They tell us that the velocity is 30 meters per second already, and then they give us a specific gravity for each situation. So we're going to start off here on Earth, where gravity is 9.81 meters per second squared. So our velocity is 30 times the square root of 2 times our gravity of 9.81, and then h. And we want to solve for h. How do you get rid of a square root? You square both sides. 30 squared is 900. 2 times 9.81 gives us 19.62h. Then divide both sides by 19.62. And you get h equals 45.87 meters. Okay, same thing for Mars, except our gravity has changed now to 3.72, but we do the same process this time around. So we have 30 equals the square root of 2 times 3.72, and then h. Again, to get rid of a square root, you square both sides. So you get 900 equals 2 times 3.72 is 7.44 times h. Divide both sides by 7.44. And you get h to be equal to 120.97 meters for part B. Okay, almost done. We have 3 more problems left, people. So, solve the equation, check for extraneous solutions. Give this one a try. Your answer should be 59. If you got that, you're good to go. Continue on to the next problem. If not, here we go. We're going to add 4 to both sides because we want to isolate the radical. We have the cubed root of 2x plus 7 equals 5. How do you get rid of a cubed root? Well, you cube it. So we're going to cube both sides. So we're left with 2x plus 7 equals 125. Subtract 7 to both sides. 2x equals 118. Divide both sides by 2. And x equals 59. Now remember, with these, you also need to check your answers to make sure that works. So we're going to take that 59 and plug it back up into the original equation. So we have the cubed root of 2 times 59 is 118. So we have the cubed root of 125. The cubed root of 125 is 5. 5 minus 4 is 1. Does 1 equal 1? Yes. Yes, it does. So x equals 59. Okay, next one. 3x plus 21 to the 4/3 power plus 9 equals 90. Try this one on your own. Check out the answer when you're done. The answer is 2. So if you have 2, you're good to go. If you did not get 2, here we go. We're going to subtract 9, subtract 9. 3x plus 21 all to the 4/3 power equals 81. How do we get rid of a fractional exponent? Well, we're going to put it to the power of the reciprocal of that exponent. So the exponent is 4/3. We're going to do the reciprocal of that 3/4. So we have 3x plus 21. These 4/3 and 3/4 cancel out. Equals 81 to the 3/4 power. That means the 4th root of 81, which is 3. 3 cubed is 27. Subtract 21 to both sides. 3x equals 6. Divide both sides by 3, and x equals 2. Are we done? No, of course we're not done. We have to check our work and see if it works out. So we plug it back into the original equation. So we have 3 times 2 plus 21 all to the 4/3 plus 9 equals 90. So 3 times 2 is 6. 6 plus 21 is 27 to the 4/3 plus 9 equals 90. 27 to the 4/3, that's the cubed root of 27, which is 3. 3 to the 4th power is 81. 81 plus 9 equals 90. Does 90 equal 90? Yes, yes, does. So that means x equals 2. And the last problem for our review today. Solve the equation, check for extraneous solutions. So now we have x plus 2 equals the square root of the quantity 2x plus 7. So the right-hand side is being squared. To get rid of a square, to get rid of a square root, we square both sides. So that means we're going to use that forbidden math F word that I am not allowed to say, but I'm allowed to write. So that's what we're going to do over here on the right-hand side. So x plus 2 times x plus 2. So we're left with x squared plus 2x plus 2x plus 4 equals, on the right-hand side, 2x plus 7. I'm sorry, I forgot to show you guys the answer to see if you could check your work. The answer is 1. All right, so we're going to get everything to the side where the x squared is positive. So that means put everything on the left-hand side in this case. So we get x squared plus 2x minus 3 equals 0. At this point, you can do a couple different things to solve the problem. You can do the quadratic formula if you like, but that's a bit of overkill. So I'm going to do factoring. So what numbers multiply to be negative 3 and add to be positive 2? Well, it's going to be a positive 3 and a negative 1. And then we're going to set both of those parentheses equal to 0. So x equals negative 3. X equals positive 1. But are we done? No! We need to check our answers and see if they work. Because if you can tell by the answers I've already showed you, one of them does not work. So we're going to take that one in first, negative 3. Plug it back into the original equation up here. So negative 3 plus 2 equals the square root of 2 times negative 3 plus 7. Negative 3 plus 2 is negative 1. On the right-hand side, 2 times negative 3 is negative 6. Negative 6 plus 7 is 1. The square root of 1 is 1. And does negative 1 equal 1? No. No, it does not. So negative 3 cannot be an answer to this equation. Now we're going to try and see if 1 works. So we're going to plug that one in. So we have 1 plus 2 equals the square root of 2 times 1 plus 7. 1 plus 2 is 3. 2 times 1 is 2. 2 plus 7 is 9, so the square root of 9. Square root of 9 is 3. Does 3 equal 3? Yes, yes it does. So x equals 1. That is your answer. So, good luck on your quiz tomorrow. Hope you guys had a nice extended 4-day weekend this weekend. Have a marvelous day.